Hello. Today we are going to see ubiquitous systems. In this, we'll see edge computing, cloudlets for computing, Internet of Things, virtual computing, virtual events like 2D, 3D, or hybrid events. The ubiquitous computing, it was been first defined by the Mark Weiser. In that research paper, he said about the three basic devices in very old time that there could be possible tabs which could be variable devices that could be approximate to the centimeters. Then he also said about pads should be there like iPad of Apple, like Samsung. So it could be approximately around the decimeters, and they could be hand held devices, means you can have it on the hand. Then so these type of devices are very common now. Then there's this board type of device also possible, that is having the interactive large display device that could be approximately for the meters in a size. So a meter means it could be large enough on the board, means you can put it down and you can have a touch and keep on working. Then what is ubiquitous computing that he defined? He defined this as computing which is made to be appear at anywhere, at any place, or at any time, so that you could have the computing process everywhere. For example, nowadays you are using mobile phone or you are using the content available on the cloud. So it's like you are computing anywhere with your mobile, Android or iOS. You have laptop moving around anywhere where you go. You just need a connectivity of internet, and then you have the computing of server at any point of time or anywhere. Then what are the devices I already told: Android, mobile phone or tablets or laptop. At any location where you go, if they have connectivity, you can compute at your local desktop or at the server as well. Then any kind of format file could also be possible to be used on that. Next, edge computing. So edge computing, it belongs to the distributed computing paradigm. How it belongs? It is doing the computation and data storage closer to the user location. Means when you are doing the internet access and doing the processing of the files on the internet, so it would be better that these files were kept nearer to you, because it would be convenient for you as a user to retrieve it and have the fast availability. That is the purpose of edge computing. So it brings cloud closer to the user. Then it improves the response time and saves the bandwidth. So this the main benefit was lower response time of getting those files or images or videos, and it saves the bandwidth. Means if it's nearer to your location, then the less amount of traveling for the network would be required. Thus it saves bandwidth. Then cloud computing operates on the big data. How it operates on the big data? Cloud computing has large can generate large size of data which could have large volume. Thus the cloud computing relates to the big data. But edge computing operates on instant data. Why? Because the data that you request would be respond immediately. That's why edge computers are keeping those data nearer to a user, so that you could or user could easily get the access to the instant data. Means the images that are requested most frequently, they should be kept nearer to those users. Next, content delivery or the content distribution network. So edge computing has two type of networks that were being defined, and they both belongs to the same category, and they have the alias, means they are of same type, but they have the two different names, and they are being called as CDN in common. That content delivery network and content distribution network. Then the examples are like Akamai CDN, Akamai Facebook photo serving stack. In the Akamai CDN, you have the Akamai is a company which provide content delivery network where you can access the your content very easily. And Akamai provides this content delivery network to the Facebook for photo stacking. Means if you ask for the photo to the Facebook that you want this photo on your account, then the call will go to the nearest CDN content delivery network of Akamai, not on the Facebook. Means the Akamai will respond you the and give you the photo that you had requested, image that you had requested. So this is what the purpose of CDN. It would be nearer to the user, and the Akamai will respond you that this image was being requested by your Facebook account. Next, Cloudlet. So it was first coined by Mahadevan Satya Narayanan Satya and Victor Behel and Raman and Nigel. Then what was the purpose of this? It's the purpose is mobility enhancement, means increasing the movement of our devices is, which could be having a small scale cloud center nearer to it, so that you could have better computing. And the edge edge means the nearest computing device or server could be available to you on internet. So it works like a nearer data center, means a data center in a box, means it's very nearer to you as a user, and it brings cloud closer to you. Why it is being used? So it has been used because of the sometime resource intensive things are required, and interactive mobile applications are being required. So these type of cloudlet provides and do computation for this, and thus it actually optimize the resource of mobile devices which could have lower power generation, like batteries of the mobile is limited. So it supports your mobile battery by bringing the data content from the nearest server, which is said to be cloudlet or edge center, data center. Or like for example, you are going with a ship. So in that ship, or it's merchant navy ship or some defense ship on the ocean, and there's very difficult to connect with the network or with the server. So what it does a local server which is connected to a large battery, or the server is a local data center, and it actually communicate with the world wherever the content was kept. So when you request some of the content from your mobile when you are roaming on the ship, so the request goes to the local data center, means on the ship, and that local data center connected with large batteries will actually request the world data center wherever it is being kept, Silicon Valley, Hyderabad, or Bangalore. So request goes to them, and the content will be came to the local data center, and the local data center like cloudlet or edge data center will actually respond to your mobile on the ship. This is the real example. Then next, fog computing. So fog computing also belongs to the similar kind of data structure, or the cloud structure, or the computing structure, where you actually distribute the computing or storage or control networks, so that the function could be closer to the user. The same thing means bringing cloud nearer to the user. How the fog computing works? It actually cloud to the things, means cloud things that are the things that require cloud. Some of the things on the world requires the cloud. So the fog computing brings closer to the that thing. Then the fog computing is often erroneous called as edge computing, but they are actually different from each other. So fog computing and edge computing are different from each other. How they are different? Fog computing works with cloud computing. So cloud computing and fog computing works together. But whereas edge computing is being defined in the exclusion of cloud computing, means edge computing and fog computing are being different from each other, and they are not that much related, but fog computing is inside the cloud computing. Then fog is a hierarchical edge that tends to be limited to a small number of layers. It means that there are few hops or the few edges, means few nodes that could be possible of the server, and the fewer layer are required for the answering to the user request and response. Then cloud computing basically deals with big data. Again, the cloud computing deals with big data, whereas fog computing deals with the real time data. Again, like the edge computing, fog computing also deals with the instant data, real time data. But in this case, fog computing is actually the cloud of things. So cloud things means things or object, the electronic devices that you see in the daily use are actually requesting the cloud, and the fog will be responding to that. Thus the main data that fog computing deals with are being generated from the sensors or the users. Thus the fog computing is actually inside the cloud computing. Next, very common and very popular terminology, Internet of Things. This is basically for the physical objects. What are the physical object or things that actually available around us? Like there's smart televisions came up, smart speakers came up. So these smart speaker or smart televisions are actually being connected through the internet, and they are basically how they are being connected. They are being connected with some of the intelligent sensors, softwares, or some other technologies like Bluetooth. What are the purpose of these sensors or Bluetooth or the Wi-Fi connected to these intelligent devices? Are the purpose is connectivity with the internet or the other devices, for exchanging the data from internet or from the other devices that you have, so that the data could be shared from pen drive to the local television, a smart television, or you have a Bluetooth to connect with the smart television, and you can see the mobile data on directly on the television. Then the other devices or the or over the computer. So the connectivity and the purpose of all these things is just connecting and exchanging the data from other devices the user possess, and connect with the data exchanges with the system over the network or internet. Then what are the common example that we see is smart home devices or appliances, like I already told, smart television, smart AC, smart air conditioning, and smart speakers are there. So these are the homemade devices, home devices, smart home devices. Then you have smart cities, equipments are there, like there are lights, traffic lights are there. So the street lights are there, they are also connected with the internet, and they are also having very intelligent to behave that now it's evening, so the light is required. Now it's morning, then the light should be turned off. So they actually behaves intelligently. How they behaves? They are actually connected with the server internet, and they manages the time accurately. Then the these type of devices are available, equipment or facilities are available on the smart cities. Then real time data analytics are required for the internet of things. Why? Because on the daily basis or the on the hourly basis or every day or weekly basis, the data keeps on generating, so you need a real time analytics and processing. Then information explosion or data diligence means Due to the large number of sensors and large number of data produced by them, there is large data which could be generated that create data flooding and information flooding, because it keeps on ever increasing the demand of electronic data exchanges, or every hour or every week. So that's why the amount of data or the electronic data will keep on generating more and more. Then there is a competition or the comparison between the unmanageable data which was being generated by sensors and other devices versus the data processing power, means the data was being generated every hour or every minute, then you need to process that as well. So data processing means the algorithm that you write and the computational power that you have should match up with the data generation by the sensors or other devices. Next, virtual conferencings, like daily basis or at many places teleconferencing was there. At the older times, phone lines are there, landlines are there, cellular devices are there, but now the modern era came up where you do the video conferencing, where you have webcam, microphones, speaker and internet hardware and software aligned with all these webcam, microphone, speaker and internet, so that the hardware and software work properly and devices could work properly and do the video conferencing for this purpose. Then what is the modern way, even much further way, is web conferencing, where you have the internet and cloud support available, like you have Google Meet available, Skype available, Microsoft Team available, and this was being promoted by the web 2.0. So web 2.0 is an era where the user or the modern kind of web technologies were there, like Google Meets that we are discussing. Then multi communication from the many sender to the many receivers. So it's possible with these type of Google Meet or Skype, you can have multiple persons communicating with each other. Then webinar, web seminars, webcast, live media presentation, podcast, audio presentation, or web meeting type of things could be possible with such virtual video conferencing. Then virtual event is one of the important thing which are going on. That is what is virtual event, we'll discuss in detail. The online event that involves people interacting like they are interacting in the physical world, so just imitating that physical world in the virtual environment of cloud or virtual video conferencing is said to be virtual events. Then multiple sessions or multiple online events could be possible with the webinars or the webcast going on parallel. Then the aim of all these things is to just have a experience of the physical meeting. Then the advantage of this is like live streaming of the event online and on demand video, that the video of the live stream is being recorded, you can see it after some time when you are, whenever you are free. Then what are the issue and the problem with the virtual events is like echo of voice, that two different devices were echoing, means they are speaking, one is speaking and then other device is repeating it, and then again the first one is repeating the, so the echo will keep on happening. Then audio video logistics, means you need some audio, better audio device, better videography device, camera is required. Then there's requirement of large bandwidth because of the video conferencing and the server and users. Next, we'll discuss that there are different type of virtual events possible, like 2D events, where you have the this example showing that the virtual degree distribution in 2 dimension only. The simple video was playing and there's a degree being called out for the distribution. Next, there could be virtual addressing possible, that the eminent personality like education minister can give the presentation for the virtual degree distribution, that I got degree from IIT Indore in the convocation 2020. Next, I attended a three-dimensional virtual event which could have a live video streaming on the some screen. How it's possible that there is a screen which is showing that the video was being published when you go in the virtual avatar in the auditorium. Then you can also have virtual posters in the 3D animated way. But that posters was not that clear. How that could be clear? When you click on the rounded symbol, then the whole PDF, so the PDF will come out in front of your screen, and you can on detail read the PDF. You can do the zoom in, zoom out, or you can copy paste line, or you can do the extraction of the content, or you can study it in the detail. You can zoom in the figures and see it properly. So the PDF will will come out of that when you click on the symbol. Next, you can have the virtual gathering by calling and speaking. When you press the space bar, you can speak. When you speak, the it will be same as the virtual uh, video conferencing. So these virtual avatars are actually been talking to each other. Next, you can have a virtual dancing event, like you have various gaming app. So you can have gaming and dancing also possible. Next, hybrid event could also be possible, where there's a physical in-person event is going, as well as there is a virtual online event is also going. So what are the example of this? Trade show, conferences, seminar, workshop, or convocation. So we'll see the example of convocation. Like this was the front end and landing page. You can, by clicking on various red dots, you can go to the auditorium, agenda, chat support, and mosaic wall. Then you can have uh, the LNMIT's convocation 2020 details, like virtual degree distribution could be possible, where there's a physical event going on, and parallelly the only the picture of that student was being shown. Then it's possible to have the physical degree distribution as well, where the physically the degree was being also being distributed. Next, we'll see the distributed version control system. I hope you had enjoyed the ubiquitous computing. So next we'll discuss about the distributed